Hey, this is Mr. Gagnon. We're going to talk a little bit about two-dimensional kinematics in a typical cliff problem. Now, when I was younger, we used to watch something called the Roadrunner, and the Roadrunner would be a bird that would be chased by a coyote. His name was Wile E. Coyote, and the coyote always ended up falling off the cliff and hitting the ground. That probably isn't so politically correct at this point. I showed my son a clip of that, and his mother was really upset. But anyway, back to the story here. We have Wile E. Coyote running off the cliff, and we can say that he's running off the cliff here. And let's make this a little less violent. We'll say that there is a trampoline right here. Okay, a little trampoline right there. We know that the velocity, we'll say that the velocity in the x direction, which is this one here, let's say he runs off at 5 meters per second, okay, to the right. Okay, now when he goes off the cliff, he's going to move out some distance and then go down and hit the trampoline. Okay, so we got to kind of figure out, number one, how we set this problem up, and number two, what we're asking for. So we're asking for a couple of things. Okay, we want to know where to place the trampoline. Okay, we want to know the x, the displacement, and we also want to know, like, maybe with what velocity he's going to be hitting the trampoline at. We'll consider this to be the 0 mark. Okay, so now one thing to consider is that the x and y velocities, okay, I'll put a little side note here, x and y are separate entities. They're separate. Okay, they exist separate from each other. So this actually turns into a problem, a free fall problem. So if this person were to just fall right there, then it would be the same amount of time as if they were going in the x direction. Now the other thing we want to note is that the velocity in the x direction equals 5 meters per second throughout. Okay, throughout the entire thing. That means it's going to move this way, 5 meters per second, 5 meters per second, throughout the entire process here, because they do act separately. And there's nothing, assuming air resistance is negligible here, there's nothing stopping this person, or whatever you want to call it, an object, going to the right. Nothing stopping it until it hits the ground. The ground or the trampoline is going to stop it. Okay, so let's say that the height here, okay, y equals, we'll say, negative 100 meters. Pretty high cliff. Okay, so we know that the x remains constant. The y is going to change. Velocity in the y direction is changing with acceleration of gravity. Okay, so we know that. So let's get this cleaned up a little bit. Okay, we know, number one, that Vx is 5 meters per second. We know that V O Y, or V naught Y, the y direction is 0. Okay, we know that. We know that the y displacement is negative 100 meters. Okay, we've just figured that out. Okay, we also know that the acceleration of gravity is negative 9.8 meters per second squared. Now let's think for a second. What else could there be in this problem that we're missing here? Well, we're looking for x. Okay, that one. We are looking for VFY, VF in the y direction. And let's go from there. Okay, so since this is a regular free fall problem, okay, because it's going horizontal, this thing is just going to consider to be falling. So I'm going to go and I'm going to always look for the time first. Now, if I look at my kinematics formulas, without an initial y velocity, the time that it takes is equivalent to 2 times the displacement over the acceleration of gravity. So let's figure out how long this fella takes to hit the trampoline here. Okay, so let's see what we got here. So 2 times 100. So you've got the square root of 200, negative 200, over negative 9.8. So 200 divided by 9.8 is square root about 20.4. Okay, and then the square root of that is the time, about 4.5 seconds. So during this entire process, this guy or coyote or whatever is in the air for 4.5 seconds. Okay, that's important because he's also moving to the right at 5 meters every second. So we can actually get the x here, okay, because we know that displacement is velocity times, we'll say velocity in the x direction, times time plus half at squared. Now, because it's going to the right consistently, okay, there is no acceleration. So now we boil it down to x is vxt. So x, this displacement here, is the velocity in the x direction times the time in the air. So we had 4.5 seconds. So 5 times 4.5 is, well, we better put that trampoline about 22.5 meters away, because that's how far this fella is going to be off the base of the cliff here. Okay, so that is our displacement in the x direction, 22.5 meters. Now, I'm going to stop there because we're just going to use that to get the x displacement. In a further video, we'll talk about how to get the final velocity in the y direction, which I think you already know how to do. But then we can also figure out how to get the final velocity in general of the entire thing, because now we've got we've got 2 velocities to deal with. Okay, so that'll be it. That's a long enough video. We know that they move in the x direction at a constant velocity. They're accelerating in the y direction. We can get the time in the air and then multiply that time by the velocity in the x direction. Thank you, and have a great day.